So now we're going to solve by factoring. Something to point out, notice that there is a domain restriction. We're only going to be looking for the angles from 0 to 2 pi. So what I need to do first is find the product. I get the product by multiplying the ends. And your product is 2 times negative 1, so that gives you negative 2. Your sum comes from the middle term. So my sum, and since this is a negative 1 sine x, my sum is negative 1. So I need to find two numbers that multiply to give you negative 2 but add to give you negative 1. And that combination is negative 2 and positive 1. So I'm going to have sine x minus 2 and a sine x plus 1. Now, since I'm dividing by, I have a 2 in front, I'm going to divide all my factors by 2. Now, since I'm solving, reduce it down. If it reduces, simplify it. So this becomes sine x minus 1. But over here, normally if you're just factoring, you'd want to bring the 2 out to the front. But since we're going to solve, if you think about it, we're just going to undo the process anyway. So I'm just going to leave it as sine x plus 1. But when I divide by 2, this ends up being sine x plus 1/2. So I'm going to leave it as a fraction. So now that I have it factored, now I set each factor equal to 0. So I have sine x minus 1 equals 0. And I have sine x plus 1/2 equals 0. Now to solve, add 1 to both sides, and I get sine x equals 1. And I need to find all of my angles from 0 to 2 pi that makes sine equal to 1. And there's only one place that happens, and that is at pi over 2. So that one's done. Go to the other side. Sine, I get sine x equals negative 1/2. And sine's going to give me negative 1/2 in 2 quadrants. And I'm going to be in quadrant 3 and quadrant 4. So one of my angles will be, my reference angle is pi over 6, so I'm going to have a 7 pi over 6, and I'm also going to have 11 pi over 6. And since we have a restriction of only going from 0 to 2 pi, I'm only going to have 3 answers for this.